The iterable interface represents an object that is iterable. That means we can iterate or loop over it without knowing anything about its implementation detail. So we are using an array here. If we decide to replace this with an array list or a different data structure in the future, the clients of this class are not going to get affected because they're going to code against the iterable interface. Back to our remote control metaphor, think of the buttons for changing the volume. If the internal implementation of this remote control changes, you're not going to get affected. You're still going to use the same buttons. These buttons are the interfaces that you work with. So we want to implement the iterable interface in this class, and then have other classes that use our generic list program against the iterable interface. It's like saying that they use the volume control buttons on a remote control, okay? Now, here's the documentation for the iterable interface. As you can see, this interface declares 3 methods. The first and last methods have a default implementation, so we don't have to implement them. The only method that we have to implement is this method over here, iterator. It returns an iterator object. We're going to talk about iterators in the next video, but very briefly, an iterator is an object that we use to iterate over an iterable. Now, I know the name is confusing, but don't worry, I'm going to make it super simple for you. So back to our generic list class. Here we type implements iterable of t. So this is also a generic interface. Now we press Alt and Enter and have IntelliJ implement the methods. So here you can see the same 3 methods that I showed you. The iterator method is highlighted because it's a required method. So let's press OK. And here you can see the iterator method. For now, don't worry about the code we're going to write in this method. We're going to come back and complete this in the next video. All I want you to pay attention to is the return type of this method. It returns an iterator object. So back to our main method. Now that our list implements the iterable interface, we know that it has the iterator method. So we call it to get an iterator. And with this, we can iterate or loop over our list without knowing anything about its internal implementation. So we can write code like this. While iterator has next, we're going to call iterator.next. This will return the current object. So we store it over here and then print it on the console. What's going on here? Well, imagine our list looks like this. So we have A, B, and C. This iterator is like a pointer that is pointing at one object. So initially it's pointing at the first object. At the beginning of our loop, we ask, do you have more items? It says yes. So here we call the next method. This will return the current item, which is the A, and then it will advance the pointer to point to B. In the next iteration, we ask the iterator, do you have more items? We still do. So this method will return true. Then we read the current item and advance the pointer. One more time, we read the C, and then the iterator ends up here. So in the next iteration, when we call the hasNext method, we'll get false. So this iterator is simply an object that we use to iterate over a list, or more accurately, an object that is iterable. Now, let me show you something really interesting. Let's compile the code. Then, from the project window, let's select the main class and look at its bytecode representation. Take a look. So over here, we have a reference to iterator.hasNext and iterator.next. Now, I'm going to delete all the code for using this iterator object and instead use a for each loop. So for each item in list, we're going to print each item. One more time, we're going to compile the code and look at the bytecode representation of the main class. Take a look. We still have a reference to the iterator object. So the for each loop is actually a syntactical sugar over the iterator object. When we use the for each loop, the Java compiler will convert our code to use an iterator object. This is the reason why we can iterate over this list using a for each loop. Now, if I remove this bit of code over here, implements iterable, and go back to the main class, you can see we have a compilation error saying for each not applicable to type generic list. So this is the benefit of implementing the iterable interface. It allows us to iterate over an object without knowing anything about its internal implementation. So I'm going to bring this back. Now, if tomorrow we decide to replace this array with, let's say, an array list, our for each loop is not going to get affected. Now, our implementation is not complete. We still have to implement the iterator method. And that's what we're going to do next.